Yo, what's up, guys? It's Stefan from Wondergraph, and today we're going to talk about a topic that many developers and data enthusiasts love to hate on: object relational mapping, also commonly known as ORMs.
No. Wait.
But before you head to the comments and you start yelling about ORMs, let us first introduce the universal ORM. The universal ORM is a TypeScript ORM that gives you a single unified API for access for all your data sources. So from REST, SOAP, GraphQL, SQLite, MySQL, Postgres, anything. This is a huge step towards making an ORM that we actually like to use. And listen, I'm not hating against the other ORM providers out there. I'm a huge fan of Prisma, but it did come with some limitations. And now Drizzle, they've been doing an absolutely fantastic job, and I've tried them out and I really do like it. But for me, the biggest thing is I haven't found an ORM that I like to use with APIs. What I mean by that is that traditionally we've been building monolithic applications. This means that we can call into any part of our application with a function call. But over time, we started splitting up our applications into smaller composable parts, microservices. In addition, we started using SaaS services. Both of these trends, microservices and SaaSes, they've led to distributed systems. And to communicate between these distributed systems, we're using APIs. However, using an API is not as easy as calling a function. And there's a lot of boilerplate involved, especially when you're using multiple APIs from different vendors with different API styles. REST, GraphQL, SOAP, RPC. And to solve this problem is why we built the Wondergraph ORM. We want to make APIs more accessible. A lot of vendors have started providing SDKs with their APIs. However, SDKs have a lot of problems when trying to solve a new approach. All right, Stefan, enough talking about the boring tech stuff. Let's just get right into the demo and show you why I think this ORM is a game changer. What started is to create a new Wondergraph app, my app, and add the feature flow of example ORM. CD into it, install your dependencies and start. This is just using our CLI to start up a new Wondergraph project and start the development server. So for those of you not familiar, this is how every Wondergraph project starts. We configure everything through our wondergraph.config file, all our APIs, data sources, and you'll see here I have two APIs. So I have my countries API, which is a GraphQL API. I've introspected that. And I have my weather API, which is also a GraphQL API. And I've introspected those. And I plug them into our APIs list. And this is now created my virtual graph. You can add any kind of feature here or any type of data source. So introspect dot, and you'll see these are all the data sources that we support. Okay. Important thing to note, you've probably already seen this, is that we have the experimental flag on. We believe it's there to ship fast and get feedback, so you have to trigger ORM experimental on. So just in case you find any bugs, please report them in the Discord below, but make sure you have this triggered. Okay, so now that we got a small refresher of Wondergraph, let's get right into the ORM. We're going to do a very simple example where we fetch some data from a country, including the capital, and then fetch the weather from the capital city from another API and through our ORM, and it's going to be type safe the whole way through. So the first thing we want to do is we want to head over to operations, which is an empty folder right now. We're going to create a new file called country.ts. And for the sake of this demo, I'm actually going to just copy the code over, but don't worry, we're going to explain what is going on. You'll see here, I just posted some code in here. Let's kind of walk through what's happening. So you'll see here, I have const Germany equals await. And here, what this is doing is it's an API call which fetches the data from the country's API. The second one has type safe access to the response of the first API call, and it fetches the correlated weather data from weather. In addition, down here, we're using the select method to reduce the response payload, which also reduces the TypeScript types of the response at the same time. Next, this whole operation is wrapped in our create operation.query. This is just simply a function call which uses the TypeScript AST in compile time to not just generate TypeScript models for the generated client, but also a JSON schema for the response. Why is that important? Because for the generated JSON schema with the response, it also generates an open API spec as well as a Postman collection for the resulting API. So I know that was a mouthful, but we'll walk through it some more, don't worry. So let's hit save. And so now I've just used my ORM to combine two APIs and get the exact data that I want. So let's switch over to our browser. So you'll see here, I have a Wonder node. Let's head over to that endpoint. So you'll see here, I'm able to get all the information that I just asked for using our universal ORM, and I combine two APIs together. It doesn't even have to be APIs. It can be databases, types of data sources, and APIs of all variety. So SOAP, JSON, REST. I mean, the list just gets longer and longer. But let's kind of talk about the how. So when you introspect an API here, WonderGraph will do a couple things for you. It'll introspect all sorts of the APIs and create a universal GraphQL schema across all of them. We call this the virtual graph because it's a virtual representation of all the APIs you're using. And with multiple APIs, they might have the same type with the same name. We prefix all the APIs with an API namespace. Next, which is the ORM part, we generate a TypeScript ORM on top of this virtual graph. This ORM is aware of the virtual graph and namespaces, and we're also generating TypeScript type to make. So from, query, where, select, and X type safe. When you call X, we're internally generating a GraphQL operation and send it to the internal GraphQL endpoint of our API gateway. The API gateway will then parse, plan, and optimize the operation against the virtual graph, which will then be cached so it can be used efficiently. And we're kind of using the reverse API gateway pattern for all the ORM requests. We're not just able to optimize all sorts of things behind the scenes, like caching and batching, but we're also able to generate complete traces using OpenTelemetry for all your API calls for your application is making. So an example, if you create an API endpoint that calls two APIs where one depends on the other, you're able to see the latency of the whole request and a breakdown of the latency for each of your API calls. This will be coming in another video where we talk about our OpenTelemetry, Prometheus, our logging, and just how amazing our logging has gone in the recent weeks. So there you guys have it. You guys can try out the ORM today. It's super easy to get started. We have full documentation on it. And we also have a full blog post that lists all the things I wasn't able to cover in this video. I wanted to keep the video under 6 minutes. So go ahead, give the blog post a read, and you'll see why SDKs are not the approach to go and why this universal ORM is such a game changer. Try it out today. Make sure you add the experimental flag. Remember, it's not production ready. Let me know what you guys think in the comments below about this video. See you next time. Peace.